Okay. Let me data. Which one are the data sheets?
It depends on what, if we're talking about your project, it depends on what pick you're planning to use.
Okay, so there's I think the F8877. Let me share
The
my
18877, yes.
screen share. Okay, this might be the wrong the wrong one.
That's the silicon errata, yeah.
Sorry about that. Data sheets 1877.
No. Look carefully, there are 3 of them, right? Okay, now show your table of contents. Very good. Okay, now we're talking about the analog to digital converter, yes?
Yes, miss.
All right, let's go to that section.
I did actually read it from here, I think, but
Just look for the name of the chapter, otherwise you'll be looking forever.
oh, sorry. Analog to digital.
There you go. All right, good. So this is the section we're looking at, right?
Mm-hmm.
Okay, and we read this in class, right? Remember?
Yeah, I also
All
read
right.
it during assignment
So
week,
let's
but
just read the first paragraph,
the
and then
analog
let's interpret what we read.
the analog to digital converter with computation ADC squared allows conversion of an analog input signal to a 10-bit binary representation of that signal.
All right. Any questions about that sentence?
So whatever is the input, once it's high, it will return with a 10-bit binary representation.
No. It said analog. If we talk
Analog.
high and low, we talk in digital. So let's start again.
The analog to digital converter with computation ADT squared allows conversion of an analog input to signal to 10-bit binary representation of that signal.
All right. So if it's an analog input signal, can I talk about high and low?
No.
Right. So an analog input signal would be a voltage of some value. Yes?
Yeah.
All right. So what they're saying is, if it's a digital input signal, then we would talk high and low, and we would use VOH and VIH and VOL and VIL to talk about digital signals, right?
Yeah.
This peripheral is going to deal with analog input signals. So in other words, we're not getting high and low. We're going to get some number, a 10-bit number, that will vary based on the voltage.
Okay.
Read the next sentence.
This device uses analog inputs, which are multiplexed into a single sample and hold circuit.
All right. So to convert an analog signal to a digital signal, you need a sample and hold circuit. In other words, you need a circuit that is going to catch the voltage, for want of a better word, right?
Yeah.
You need a circuit that will sample the voltage and then keep the voltage constant while you're converting, because the live signal will be changing over time, right?
Yeah.
All right. So you can't convert a signal that is changing. That wouldn't make sense, right? So
Yeah.
from an electronic point of view. So they have a sample and hold circuit whose job it is to catch the voltage at a point in time and then hold it. So if we were talking controls, we would be talking about a 0-order hold or a first-order hold. I don't know if you're doing controls yet.
Yeah, I done all 5, sadly.
So you haven't talked about sample and hold in controls?
I'm not quite sure. Like what I kind of forget everything.
All right. So what I'm going to say to you is, I assume that these words make sense to you. What I'm hearing is, firstly, you had the understanding of an analog signal was flawed. Is that a fair statement?
Our analog signal is flawed.
You didn't understand what an analog signal was. Is that correct?
Okay, yeah, I didn't understand.
All right.
Well, I
So
mean, I guess I know what it was, but I was mixing it up with like how to connect this thing to the pick.
okay, and so that's what I'm saying is that if you had a problem understanding what an analog signal was, that's when you're having a problem, right?
Yeah.
So you're connecting a voltage signal that is not digital to the pick, then it would be an analog signal. We agree?
Yeah, I agree.
All right. So that is the first misconception you had as well, to treat it as an analog signal rather than a high or low. Okay.
Yep.
Once you know you're treating it as an analog signal, then this is the peripheral we're using. Okay. So now I want you to read the last sentence in that paragraph.
I think this is the last. This is the one right here, right? The
That's the
output.
next sentence. I want you to read the last sentence.
Oh, I think this is this is the last sentence.
Mm-hmm.
The converter generates a 10-bit binary result via successive approximation and stores the conversion result in the ADC result register. AD
All right.
rush.
AD rush and AD wrestle. Okay, good. Now, how many bits are in our result?
10.
10 bits. How many bits are in special function registers on this architecture?
Is it
How many bits are
8?
in 8? Very good. So clearly, if I have a 10-bit result, I can't fit in one register. Does that make sense?
Yeah.
So what they're saying is that we're going to give you the answer. And when we do the answer, we're going to use 2 registers because it can't fit in one, right?
Mm-hmm.
All right. So back to your question. One thing was you said you're not quite sure how address works. Is that
Yeah.
looking better for you there now?
Yeah, I understand how it works now.
All right. So the point is that all of the information about the E to D converter is in this section. On assignment B, the signal was coming from the flex sensor. So what you had to do was create a circuit where when the resistance changed, the voltage output from the circuit would change.
Yeah.
All right. And
Um,
then you would connect that circuit to an analog input pin. Make sense?
okay, so the pick have digital and analog input pins.
You can configure a pin to be either digital or analog.
Oh, and so if I configure a pin to be analog, then I could get the
Mm-hmm.
10-bit and store that in like a register with the 10.
Well, it will convert it, and the result of our conversion will end up in these registers, right? And then you could copy it from there into a register that you want.
Oh, that I understand now.
That's the concept that was escaping you, right?
Yeah.
All right. So let's drill back, right? Because anytime you're having trouble, you understand. For weeks, I was asking people if they had a question about assignment B, right? Because I know that sometimes these concepts have you puzzled and you're not sure what to do.
I had like get through question 1 and then like the all the time I had left was after comes to finish assignment B, but at least
Well,
I
the
attempted.
second thing I would say is that when you're tackling an assignment, read the entire assignment before you start. That goes for exam papers, midterms, and coursework. Don't just try to tackle the questions individually. Does that make sense?
Yeah,
Because I
makes sense.
realized from the answers that we've been marking that some people didn't even read the case study, which came after the questions in the handouts,
Mm-hmm.
but you needed to read that and think about the whole thing before you tackle the questions. Does that make sense?
The case study that's for the report.
The case study for assignment B.
Oh, I yeah,
So
sorry about
so
that.
I, so what I'm pointing out to you, people open it up and they start on page 1, right?
Yeah.
They didn't read the entire assignment, right?
Mm-hmm.
So why do you think that is? Let's reflect.
Why do I I just think it's the mentality that we have that we just want all the information as fast as possible to just do the assignment and get it out of the way because it just
Uh-huh.
have so much time that we
Mhm.
could just spend like if micro P was like the only subject
Mhm.
it would be so like I could spend like so much time on
Uh-huh.
a certain thing, I just like become real good at it because
Mhm.
I don't know, like it's
All
just
right. So
time.
I appreciate what you're saying, and I understand that in your experience, if the only kinds of questions I were asking you were things that you had seen before in the exact same way, then that would be the fastest way to answer, right?
That is 100% true.
However, this is engineering, right?
Mm-hmm.
My job is to prepare you for when you go out in industry, okay? When you go
Yeah,
out in industry, you are never going to see the exact same thing in the way you have seen it before. Is that a fair statement?
yeah, I'll have to
Yeah.
think.
Yeah, okay, good. So what we want you to do is to build the skills for the thinking. Now I hear what you're saying about the time management. That is a very, very excellent point. However, you will find that you actually take less time overall if you stop and read through the assignment at the start.
Well, I will implement that because it is a problem, and if that helps,
Mhm.
that'd be great.
Yes, because if you had read through the whole thing, you would have gotten to page, I think it's page 2 and 3. So there was some
Mm-hmm.
hypo on one page, which should help you contextualize. There was also a full description of what the whole system does, which explained that, it's 5 fingers and each finger is connected to a different analog input. It also explained that we will copy and reading from address to different bytes. You understand what I'm saying? So it would give you some context. Okay.
Yeah.
All right, good. Now, the next question you have here in the chat, how to get the values from a modulated input from a port. Is
Well,
that the same story about analog inputs?
yeah, because
All right,
what
good.
I mean by modulating, like it changing and huh?
Right. So that is the same point, right? You use the A to D converter, right?
Mm-hmm.
You configure the A to D converter so it's going to sample from the pin that you have your signal connected to, right? And it's going to give you a number. The number it gives you will range from 0 to whatever the maximum is, okay?
Yeah.
And the way it converts the voltage is it looks at the reference voltages, okay?
Mm-hmm.
So if my reference voltages was 0 and 1, then I would get a 10-bit reading. When the 10-bit reading is 0, it would refer to a voltage of 0. And when the 10-bit reading is all ones, it would refer to a voltage of 1. Make sense?
Yeah. Um.
So your reference voltages determine what the binary number means. Okay?
Okay. This quick question. This A to D
Mhm.
converter is built in into the PIC to be configured, right? For
Yes, it is. And if you scroll to the next page, that's the block diagram for that A to D converter.
all ports have
So,
this, or is like special ports?
well, that is a good question. So that's why you read the datasheet to find out, okay?
Okay.
So you'll notice based on this sample circuit, to the left side, you see it says external channel inputs, AN0, AN A to Z, right? So it's
Yep.
those external channel inputs we're interested in connected to, right?
Oh, okay.
We also notice that on the right-hand side, there's a clock source. So you need to configure the ADC. On the right-hand side, you'll see there's a clock source. We need to set that clock source up for the ADC. In other words, the ADC needs its own clock source in order to operate, right?
Okay.
All right. Now, if we look at the bottom of the block, on the right-hand side, you'll see where the 10-bit result comes out, right?
Mm-hmm.
And based on the value of a bit named ADFM, that determines how the 10 bits are placed in that pair of registers, whether they're left justified or right justified, okay?
Okay.
All right, at the bottom of the block, you'll see that whether or not the ADC is operating or not is determined by a bit labeled AD on that will start the entire ADC circuit operating. If the AD on bit is not on, then we will disable the ADC. So for example, imagine you had an application that doesn't use the ADC at all. You could just disable it because you're not planning to use it. Does that make sense?
Yeah.
All right. And on the right-hand side, just where you're looking there now, all of this circuitry there has to do with when you start sampling and when you finish sampling. Because remember when we talked about that sample and hold, right?
Yeah.
So you have to have a sequence. It has to catch the voltage, disconnect, and hold the voltage while we converting. When it's finished converting, it needs to reconnect, catch a new voltage, disconnect, convert that voltage. That's how it's going to work in sequence. Make sense?
Yeah.
All right. Now you
This.
asked a good question about where the inputs come from.
Yeah. So the inputs come from these three right here.
Well, not those.
Those three
That's not
ports.
three. Well, that's not three. Notice they say AN0, ANA, and then they have dot 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 down to ANZ.
Oh, so all of the AN ports.
All of the ANs, right? You got it. Okay. So now we want to know about what inputs. So again, we're going to use our table of contents. I want you to expand the table of contents for chapter 23. Okay, you see it has all the various things. Yes, it says configuration, operation, acquisition requirements. You see that we want to look in those three sections there, right? So let's go
Okay.
in configuration. All right. And in configuration, let's have a look, right?
Mm-hmm.
You see, it tells you how to configure. So let's start in section 2311, and I want you to read that out loud.
When configured and using the ADC, the following functions must be considered. Port configuration, channel selection, ADC voltage reference selection, ADC conversion clock source, interrupt control, result formatting, conversion trigger selection, ADC acquisition time, ADC recharge time, additional sample and hold capacitors, single/double sample converters, conversions, gatherings, outputs.
All right, now we don't need all of these options, but those are all the options they're going to explain to you here, all right?
Okay.
So let's start with port configuration. Go.
The ADC can be used to convert both analog and digital signals. When converting analog signals, the I/O pin should be configured for analog by setting the associated tris and uncial bits referred to section 1.0 I/O ports for more information.
All right, good. You follow that point? So in other words, when you know which pin, not only do you have to set the tris register, but you also have to set the ancel register. Make sense?
Yeah,
So
but
if it's port B,
inputs.
I'll be looking at tris B and ancel B. If it's port E, I'll be looking at tris C and ancel E. All right? So that's the
Okay.
first thing. Yeah?
Mm-hmm.
All right. So now let's look at the channel selection, which is what you were asking about next, right?
Yeah. There are several channel selections available: 8 port A pins, 8 port B pins, 8 port C pins, 8 port D pins on this model only.
All right.
3 port E pins, temperature indicator that
Well, these are
control.
the internal ones there, right? All right. So I could choose any one of these channels. You see, I have plenty channels.
Yeah,
All right. So now how do we determine? Read the next sentence.
the ADPCH register determines which channel is connected to the sample and hold circuit.
Okay. So if you want to know which pin you're converting, this is the register we're interested in. Does it make sense?
Yeah.
All right. Now what we want to know next is what to put in that register, right? So it's up to you. We could find the ADPCH. It'll be at the end of this section 23, right? So if you look in your table of contents, you see section 23.6, register definitions, ADC control. I want you to expand that section. And then I want you to find what it was named, AD something,
AD.
PCH.
Yep.
Where it gone? I think you passed it already, yeah?
It's in alphabetical order.
I don't know. You tell me. Start at the first, just read each one at a time. Add
Econ
con 0.
1. Sample, add con 2, 3. Add stat. Clock selection, ADC, reference. ADC positive, ADC.
Stop. Read it.
ADC, oh, I thought I'd see like ADC PCH.
Well, it is actually there. You didn't see
Oh,
register 23. I don't know where you're reading going so fast.
I need to put on my glasses.
All right, good. So here's the register. All right, so let's imagine we want pin B2 to be the channel we are reading. It tells us here that there are 5 bits we have to set in this register. You see that?
No.
Look at the top, stop, pause. It tells you this is the register and there's a table, right?
Yeah.
You notice bit 7 has a dash and bit 6 has a dash. And then it says we have to set bits 5 through 0, ADPCH 5 through 0.
Okay, yeah.
And then below in the table, it explains which bit pattern matches which channel, right? Okay, I want you to go down and find the bit pattern for B2.
Okay, this is B7. B1, B2.
All right, so the way that you get that pin connected to your A to D converter is you put that bit pattern into the ADPCH register. Does that make sense?
So when I put this into here, right?
Stop. When you put that in that register, and we know what instructions to do that with, right?
The trace and the add cell.
No, you're not listening. Okay. I want that value in the register named ADPCH. How do I get a value into the register named ADPCH?
Put this value in the working register and then put it into the ADPCH register.
Very good. So it's as simple as that. In addition to, you have to make sure that the trace for B2 is configured so that B2 is an input, and you have to make sure that the AND cell for B2 is configured so that it's an analog input. Make sense?
So this configures the port to be an analog input.
What we're talking about here, this configures the channel that is connected to the A to D converter. Okay. So in other words, I could have multiple analog channels, but only one can be converted at a time. Go back to the diagram if you want to double check that. The diagram is ADC2 block diagram, right? Figure 23.1. Okay, so you notice your ADC sample circuit here, there's only one input, right?
Yeah.
But I have multiple channels, right? So what that setting does is it selects which channel is going to be connected here. It doesn't configure the pin as an analog input. If I want to configure the pin as an analog input, then I would use tris and cell.
Okay, so that configuring the sampled input.
Right. So I could have maybe 4 analog inputs connected to my PIC. I would have to configure each one of them as an analog input. When it's time to convert, then I would set the channel for my A to D converter to be the first one. When I'm good with that, I would change it to the second one. When I'm good with that, I would change it to the third one. Does that make sense?
Yeah, it makes sense.
All right. So you asked me 2 questions in the chat here today. The answer was in the data sheet. Can we agree on that?
Yeah, I could agree that all possible questions probably from the data sheet.
And the exercise was for you to go in the data sheet, get your information, and then turn that into code, which clearly you know how to turn it into code because you just told me, well, if I want this, I just use the instruction that way. Yeah?
Yeah.
So the exercise was for you to go in here and look and make a decision. Now, there's always more than one way to make a decision, right? So I'm not complaining if different people have different answers. In fact, I'm more excited when different people have different answers because I want you all to understand that in engineering, There is never one answer. It's not like maths where the answers be right, okay? Does that make sense?
Yeah.
All right. So the
This.
exercises, I want you to look in here, gauge your information, and then move forward. Now, as regards the mini project, everybody has something that needs to be converted to the analog, that needs to be connected to the analog inputs. If you're doing the distance sensor, you have the photoresistors. If you're doing the what it have again, temperature sensor.
Yep.
What they have in the temperature sensor that need connecting. I know the moisture sensor is the moisture sensor itself. And the temperature sensor, I must have given you something. I think I gave you a pot, a linear pot or a joystick, right? So for the joystick or the linear pots, you'll need to use 2 channels, but it's resistive. So that's straightforward. For the moisture sensor actually generates a voltage. So you're just connecting it, but then you have to figure out how you're going to convert it, because it's not like you could control the voltage. You have to adjust your specifications to match the voltage on the sensor. And if it's the photoresistors, again, you'll need 2 channels because you have 2 photoresistors. You follow the point? So no matter what you have to do, you have to read this section to figure out how to make it do what you want it to do.
I kind of don't know what you mean by like the joystick that for the temperature
You
sensor.
have a joystick?
No.
Well, then don't worry about it.
I just have the temperature sensor, a speaker, a fan, well, the basic things that we use in the lab from the practice session.
Okay, well, I want you to go and look at your list of parts, right? So I want you to go to My Learning right now.
Got to just bring this on course.
Maybe I didn't give you a joystick. Maybe I gave you something else, right?
Yep, I am on My Learning.
Very good. Project overview. All right. So we're looking at project parts and assessment information. Okay, good. On your right-hand side, you should see something about project 1, project 2, project 3, 4, 5, or 6. So which one are you?
Project
Right-hand
3.
side. Project 3, click project 3.
My bad. Project 3.
Okay. You are supposed to have 2 linear potentiometers. So go in your bag and see if you have 2 linear potentiometers. We'll wait for you. Go and get your bag of parts and look.
Oh, yeah, I believe I have them. Yeah. Yep. I don't have a webcam though. Is it like the thing that like slide and switch?
Yes, it's a linear potentiometer. What that means is that instead of turning it, it slides. But you're going to use your multimeter and figure out how the resistance changes as it slides, right?
Oh, okay.
So you have 2 of them, right?
Yep.
So if you wanted to figure out the position of the potentiometer, you'd be generating a varying voltage, right?
Yeah.
Okay. And you have 2 of them, so you need 2 different channels, right?
Yeah.
Okay, good. And they're both resistances, so just connecting it straight to the pin wouldn't give you a voltage. You have to build some circuit where the voltage output varies as you move the part, right?
Yeah.
All right. Any questions?
I have one question regarding the voltage. And I like saw it here, not in this one. Go back. Go back. Right. Did I stop? Sorry.
You stop sharing, yeah.
Sorry about that.
Welcome everybody else. Joshua was asking some questions. If you all have any questions, ask Joshua when he's done asking his questions. Feel free.
So if the voltage is this, right?
Stop. This is not the voltage. I want you to read the section, okay? You see, trying to get pieces doesn't work, all right?
Okay.
So let's start. ADC voltage reference. Go.
ADC voltage reference. The AD ref bits of the AD ref register provides control of the positive voltage reference The positive voltage reference can be Vref plus Pn.
All right,
VDD.
stop. The Vref plus pin. So there's a pin that's labeled Vref plus somewhere, right? So in other words, I could connect a positive voltage reference externally. That's option 1. What is option 2?
VDD.
All right. Option 2 is the positive voltage reference can be VDD. Option 3?
FVR, which is 1.024 volts.
All right.
FVR 2.048 volts and FVR 4.096 volts.
If you want to know what FVR means, you see there's fixed voltage reference is FVR. There's a whole section on the fixed voltage reference.
Yeah, well.
All right, but I never asked you to use the fixed voltage reference, right? I asked you to use, if you look in assignment B, what did I ask you to use? Somebody help him out.
I have assignment B here, but I can't. I could say it's VDD.
All right, there you go. So all you need to do is
configure the reference for VDD.
Oh, there you go. And what is the negative reference voltage that I want you to use? Go back in assignment B.
Yep, I am in assignment. Well, I mean, you want to like bring it up on the screen?
No. I just asking you what's the negative reference voltage. That means VDD for the positive reference and what's the negative reference voltage. There you go. All right. Now, I want to see if you've learned how to use this data sheet, right? So I want you to go to the place where you're going to find the description of the ADP ref register and find the binary code that you need to put in it to set it to VDD.
The AD ref?
ADP ref, that's what you have there.
AD, well, this is AD ref, ADPCH, AD.
Well, let's try AD ref if you want to try that. All right. So here, you see the ADP ref bits are in it, and the ADN ref bit is in it. And the name of the register is AD ref, right?
Yeah.
So what bit pattern would I need to put in this register to get VSS and VDD as my references?
0 and...
A 0 in where?
0 in VRef. In AD ref.
Yes, what bit is that?
Bit 4.
Right. So I need a literal with a 0 in bit 4. Okay, very good. And what do I want in my bits 1 and 0?
Zero, 0.
Okay. So I need a literal that has a 0 in bit 0, a 0 in bit 1, and a 0 in bit 4. We agree?
Yeah.
All right, good.
And
so in other words, if I were to clear this register, that would work for me, right?
Oh, yeah.
All right, good. Did that help you?
It did. Just a quick question. If the voltage is like fractional, whatever that voltage is, it would be stored in as a 10-bit. And we convert that and then store
all voltages are stored as 10-bit. All voltages are stored as 10-bit. Are you asking me how an analog to digital converter works?
I guess. I mean, I think that is what you have been explaining.
Okay, well, that's an electronics question, but I will answer it, right?
Okay.
Okay. So here's a whiteboard. All right, clear. Okay, so the way an A to D converter works is it has two reference voltages, right? And you could use any two reference voltages you want. They don't have to be high and low. They don't have to be 0 and 5 volts. As you can see, we could select the reference voltages as we want, right?
Yeah.
Make sense?
Makes sense.
All right, so you have your negative reference voltage. and your positive reference voltage. Okay. Now your actual voltage will be somewhere in between there. Your actual voltage will be somewhere in between there, right? So the voltage that you want to convert will be varying at various times, and it will be somewhere in between here, right?
Yeah.
All right. So just what I was saying earlier is that we can't convert something at all times, but what we could do is we could take snapshots, right? So I could take a snapshot here. I could take another snapshot here. I could take another snapshot here. In other words, I could take snapshots at regular intervals, right?
Yeah.
In this case, it's only one channel we're dealing with. We're not changing channels. We're just going to take snapshots of the voltage at various times, okay? All right. Now, the digital number that I get will be somewhere between 0 and 2 to the n, where n is the number of bits I have available to me. All right? That makes sense?
Yeah.
Now, there are no fractions. You appreciate that? The actual number I get is not a fractional number, but it represents a fractional voltage, right? So the number I get is a whole number, right?
Yeah.
But it represents a fractional voltage, okay? So if we look at where we sampled at these 3 times, right? So for this one, that's the voltage I want, right? For this one, this is the voltage I want. And for this one, this is the voltage I want. Oops, that's the second one. Third one. I know what I'll do there. Let's just draw this one now. Okay. Imagine I had a straight line in between the 0 and the 2 to the n, right? Imagine I had a straight line between the 0 and the 2 to the n. The voltage that I get, the read is not the voltage, the digital number that I get, let me say it like that. The digital number that I get would be somewhere between 0 and 2 to the n. Does that make sense?
Yeah.
All right. So if my voltage was halfway between my positive and negative reference voltages. So for example, imagine my negative reference voltage was 1 volt. And my positive reference voltage is 3 volts. And I happen to have a signal that is at the point in time 2 volts. Yeah? I can't get volts out of this thing, right? But what I'll get is a number.
Representing
that will
the 2 volts.
Representing, not the 2 volts, representing where 2 volts is on the scale, right? So what I'll get is a number that looks like 2 to the n times my 2 volts, subtract 1. In other words, the voltage difference between my voltage and my negative reference, yeah? Divided by the difference between my positive rail and the reference. All right? So in other words, the fraction, you're right, is that we're looking at the fraction. What is 2 minus 1 divided by 3 minus 1? That would be 0.5. We agree?
Yeah.
But I can't get a 0.5 in a binary number, right?
Nah, but you could get the representation of the
I will
2
get
to the n.
I will get 2 to the n multiplied by 0.5. Okay? All right, which would be 2 to the n minus 1, okay?
Yep.
So if this was an 8-bit converter, the value I would get out would be 128. Make sense?
Yeah, that makes all the sense. Thanks. Thank you very
All
much.
right.
I understand
And that is
fully.
how A to D workers, A to D converters work in general. It don't matter if it's a successive approximation converter, a ramp converter. Remember I sent you all off to do homework to look into all the various kinds of converters?
I would assume so.
And you didn't do it. All right. So there's method to the madness, right? The reason I sent you all off to look at that is because I wanted you to understand that A to D converters all have the same principle of operation, even if they have different internals, right?
Mm-hmm.
This is how all of them work. You have a negative reference, you have a positive reference. It catches the voltage somewhere at a point in time. It's going to give you a binary number based on where the voltage you caught is relative to your negative and positive references. Okay?
Yeah.
That's all it is. It's not any more confusing than that, right? And that is the principle of A to D operation in general. So you just have to decide, okay, how many bits do I need to use? Okay? You need to decide what are my negative and positive references that I want to convert relative to, okay? And you will get a number. Now, again, that number is not 2 because, right? But if you wanted to know what the voltage actually was, you could do some maths with the number that you get out of your A to D converter to figure out what the voltage was. Does that make sense?
Yeah, I understand.
Right. And similarly, for assignment B, you could do some maths to figure out what the number that you get out, you can figure out what voltage it was related to, and you would then, by extension, be able to figure out what resistance that was related to. Make sense?
Yeah, it does.
So now bend angle, which was change in resistance, would now turn up as a change in
Voltage.
voltage, which would then turn up as a change in the value you get from your A to D converter.
Yep, and then you just find the voltage from that, like,
You do
yeah.
some maths to find the voltage and do some more maths to find the resistance, right?
Yep.
All right. And to make life simple, in question 1, I said, I want you to do a circuit because remember, you could do a infinite number of circuits to connect the resistance to the PIC, right?
Mm-hmm.
So that's why in question 1, I said, give me a circuit which, when you hook it up, you'll get a proportional voltage, a voltage that changes proportionally with the resistance. You saw that?
Yeah.
And so that would make life easy. In other words, whenever I get this number out the A to D converter, all I have to do to find out the resistance is to multiply by some constant or divide by some constant. Make sense?
Yeah, it does.
Because it's going to be proportional. Right. So that is all that whole thing was. Okay. All right. Any questions from anybody else? Seeing as Jonathan was asking all his questions. So firstly, any questions related to assignment B and what Jonathan was asking? And then secondly, any questions related to any other matters? I'm going to stop sharing, right? Oh, you stop sharing this thing. But I'm not hearing anybody, so if you're talking to me, your microphone is muted. And I'm now seeing a chat message from Caroline. Not a problem, Caroline. And who else is in the room? Shanae. And Shanae, I'm sorry I've missed you for the last few weeks, so I'm assuming you have some questions you want to ask. All right, no questions from Caroline. Shanae?
Morning, Miss.
Morning, how you doing?
I'm all right today. There's a little unclear about what I have to do for the project.
All right, no problem.
So, would
You
you
want to
be
go
able
ahead
to?
and share your screen and bring it up?
All right, I was already on it, so let me just share.
Mm-hmm.
Just Yeah, I'll see it.
Mm-hmm. All right, you are project 2. Okay.
Yes.
Mm-hmm. All right, so you have
The
your
distance.
ultrasonic sensor, right? So the ultrasonic sensor, you should already have thought about how you're going to interface that to your pick. Is that correct?
Well, I was watching stuff, but like they mostly had like on the internet, but they mostly had stuff with it being interface with Arduino.
All
Uh,
right, so you don't need to look on the internet. So this is the same conversation I was having with Jonathan. The
oh,
answer is not out there. The point is for you to formulate an answer, okay?
okay.
All right, so let's look at your ultrasonic distance sensor. Just click on the right-hand side on distance sensor and let's talk about what you want to do. Distance sensor. All right, good. So this is the distance sensor module. It has 4 pins. We see the 4 pins, right?
Yes.
All right, okay. Now, 2 of the pins are VCC and ground, so that's not so hard, right? Oh, sorry, Joshua. I apologize. Anytime I call you by the wrong name, just let me know because I call people by the wrong names all the time. And it's not okay. Okay. So we know how to power it up. We're going to connect VCC and ground, right? That's
Yeah.
not hard. We're good with that, right?
Yeah.
The other 2 pins are a little complex. All right. Now, I did link a data sheet, but you don't need to go to the data sheet yet. I want you to scroll down and read the rest of the information in here. Okay? All right. Now, it says there are 2 pins in the middle. One pin is labeled trig. And what is that?
The digital input pulse to start operating.
Okay, good. So, in other words, when I wanted to take a distance measurement, I will put a pulse on that line. Okay?
Okay.
Now it says input. Be careful. That is an input into the sensor, which means that the pin you connected on your pick will be an
Output.
very good. So, in order to get this thing to start measuring, your program needs to configure the pin as an output, and then it needs to send a pulse, which means it would go high and then low, or low and then high. There might be a delay in between. We'll look for the timing. All right?
Okay.
Good. So, do you think that's something you could write a program to do?
If I look, if I go back to notes I made, I
Right.
think, yeah.
So if we wrote some hypo, right? So step 1 would be make whatever pin I'm connected to an output.
But,
Right. Step 2 would be output a high, right? Step 3 would be wait for however long I have to wait. Step 4 would be output a low. That sounds doable, right?
Yeah.
And you break it down into pieces. So that's the approach I want you to take, right? I want you to stop and, the way to eat an elephant is 1 bite at a time. It's not impossible. All you have to do is step at a time, right? So the trigger input, yeah. And we say under notes for operation to take a measurement, supply a short 10 microsecond pulse to the trig pin. Okay, so that's doable, right?
Yeah.
All right, good. The next pin is the echo pin, which says it's an analog output interface. So, okay, a little challenging, but let's pay attention, right? It is an analog output. It is in fact analog in time rather than analog in voltage. So now let's pay attention to that, right? So sometimes you see people talk about analog. What they mean is that it's not as simple as high and low. And then to contradiction, they talk about high and low in the description. And the reason is because what they're interested in is not the whether or not it is high or low. What they're interested in is how long it is high or low. So that time is the analog value they're trying to get. Does that make sense?
Yeah.
All right, good. So I want you to read for me in the operation how this sensor works, right? So read for
Okay.
me the notes, the first paragraph,
To
and
take
let's
a,
see.
go ahead.
Go ahead.
To take a measurement, supply a short 10 microsecond pulse to the trig pin. In response, the module will send out an 8-cycle burst of ultrasound at 40 kilohertz. If the sensor detects a reflected ultrasonic burst from an object, it will raise and hold the echo pin high for a time t that is proportional to the distance of the object.
Very good. So what they're saying is you trigger the module and it by itself will send out a boost of ultrasound. And the
Okay.
physics of the thing is that if we encounter an object, that ultrasound will be reflected back to us and the module will hear it on reflection, right?
Okay.
And the module itself is going to keep track, right? It knows when it sent out the burst and it will know when it heard the reflected signal. Yes? And upon hearing a reflected signal, what it's going to do is it's going to raise and hold the echo pin high for a time t that is proportional to the distance to the object. We there with that?
Okay. Miss,
Mm-hmm.
so in response to module,
Mm-hmm.
Miss, when we say the module, what exactly we referring to?
We're referring to the sensor module because this page is describing the sensor.
The sensor. Okay. And they say okay, okay.
All right. So now that we understand how the module works, we might have to read it a couple of times, right? Just to make
Yeah,
sure we understand, right?
yeah,
But we thinking, all right, okay. So the way this thing works is I have to write my program on my pick to send a pulse on one line, and
yeah.
then on another pin on my pick, right? I'll configure
Mm,
the pick pin as an input, and I will connect it to the echo from my sensor. Make sense?
yeah,
All right. So now in my program, after I've sent the pulse, now I'm going to, in some kind of loop, check the echo pin every time I loop around, right?
yeah, yeah,
And I could count up. It's up to me. I could count how long I was here waiting on the echo pin, right? Or I could just wait until it goes high. And then after it goes high, count how long before it goes low. You see how you could do that in your code?
yeah.
All right. So I will have some count that will be proportional to the distance. So all I
Okay.
then have to figure out is, all right, well, how long was that echo pin high? And then I could do a calculation. If I know how long echo pin was high, I will know how far away the object is, right? They
Oh,
say to calculate distance, use a formula, T times C over 2, where C is the speed of sound.
okay. Okay.
Again, you're multiplying. We already talked about how to multiply. We know how to divide by 2. We definitely do. And we
Mm-hmm.
already talked about the fact that you could multiply in multiple ways if you're multiplying by a constant, right?
Yes.
All right. So your point is to figure out how you translate in whatever time or count you had
Mm,
into the distance. And once you have that, go back to your project description. Right. I told you I want it in centimeters, right? Once you have
mm,
that in centimeters, I want you to send that across the serial connection to your computer. If you want to know how to use your serial connection on your computer, check the lab practice script. Okay.
okay. Mm-hmm.
So that was the first thing. That looking less stressful now?
Yeah, it sounds less stressful. Yeah.
All right. So that's what I'm saying. A bite at a time, right? I'm not expecting you to just, vung in. But the point
Yeah.
is for you to look at it and think about how you could get that done, right? The answer
Yeah.
is not out there on the internet. The purpose of the exercise is for you to think it through so that when you reach 30/20 or you're out in industry and you're confronted with something that you need to get done, you will have practiced the steps of how you get something done, right? You look at the data sheets, you think about what you have, you say, okay, how could I make this work? And there's no one right way to make it work. There are lots and lots of different ways, okay?
Yeah.
All right. Any other questions?
Oh, Miss, so when we do all this, then on the LCD you will see a reading come up of the distance.
Well, the serial connection, the reading will come up on your computer, right?
Oh, so what exactly the LCD is for then?
All right, keep reading.
Oh, report and oh, report angle orientation of the target on of the LCD screen.
So you have a 2-line LCD, right?
Yeah,
So you're going to put the angle of the target on the top
on the
line
top.
and the
And
distance to the target, the same distance that you sent across the serial connection, you'll also print that on the bottom line of the LCD.
okay,
All right.
okay,
But
yeah,
the LCD, using the LCD and sending things to the LCD will require some other functions, right? So I
okay,
want you to start with it across the serial connection in case you have trouble with the LCD, right?
yeah,
All right. And then the cardboard target, well, you'll need to get some cardboard and put it together, right?
oh yeah,
You'll see some other information for how you could potentially build the target and the mount for the encoder disk, right?
okay,
You see it on the right-hand side under other information. You should be able to build it with things you have at home.
okay, vertical target.
Mm-hmm. And encoder disk mount.
Let's encode this one. Oh, okay,
Yeah, because you have to put a
okay, now
2-bit
see,
encoder disk on there, so
I now see.
you'll have to mount it up somehow, right?
Oh, okay,
So you could go buy Chefette and get a cup if you don't already have one in your house and build it on top of Chefette cup, right?
yeah,
We good?
yes, miss.
All right. So a little less intimidating now?
Yeah, it sounds like that. Yeah,
All right. Okay, good.
I'll stop sharing now.
Okay, no problem. All right. So I see I had a chat message. Yeah, so that was Joshua telling me that he's not Jonathan. I apologize. Okay. I also see that Camera just joined us. So I'm not sure if Caroline came up with some questions while we were looking at Shanae's project. So we've looked so far at Joshua's project and at Shanae's project. It's the same strategies using in all projects. But if Caroline or Kamraj have a specific question to ask about their project or about assignment B, I will take that now.
Miss, I am doing
Hi.
the project as Joshua, so I'm
Mm-hmm.
a little clearer now. But
Okay.
in reading the reporting and login for the week, right?
Mm-hmm.
In the last, should I share my screen?
Yes.
Okay. Right. In number 11 here is
Mm-hmm.
assessment/group contribution.
Right. So that would actually be assessed via, and I meant to put out a forum post about it. So thank you for reminding me. If you go back in the project section, you'll see there's a thing called troubleshooting. At least I hope it's there, because you know me, I always forget
Yeah,
to put the slide.
troubleshooting tables.
Pills, right. Okay.
Tables,
So
sorry. Yeah.
so you get a bonus if you post a troubleshooting tale, right?
Okay.
You could only post once with a problem, right?
Mm-hmm.
So you'll get a bonus if you post a tale. We'll assess your group contribution by your responses to other people's troubleshooting tales. So the purpose of this is to encourage people to help each other, right? So if you're
Okay.
having a particularly sticky problem, this is
Mm-hmm.
an official way to get credit for being brave enough to share it. Yeah.
Okay.
But you could only share, you only get a bonus for sharing it once, right? You could only share one, right? I want everybody helping each other do the whole thing, right? But if you're having a real troublesome problem, put it on there, right?
Okay.
And people who respond will get credit and it will go to that group contribution, right? You could respond as many times as you want. So you could post one problem, you could help 25 people. Okay?
Right. Okay.
But thank you for asking that. And Mikhail, remind me I have to put up a post. Thanks. Any other questions from anybody?
Unless we only allowed to post once and we could respond to people many times.
Exactly.
So what about if like we delete the one that we post and we post our next one?
You can't.
Oh no.
Once you post it, I think you can delete it if you do it within like 5 minutes or something. There's a window of deletion. But once it's been up there, like, a day, you can't delete again.
Like, why even ask that question?
Because he afraid he go ask something obvious. But the point is to encourage you as well to look through other people's problems. Somebody else might have had the problem you had before. So look through, yeah?
Dr. X, just for my clarity, so they would get thing based off of if they
get a bonus. They get a bonus for posting their problem because some people is really anxious about posting their problems.
Right. And that's just for
that's a bonus. That's just for posting your one problem.
Right.
And then we will be ranking the responses. So if the response is, yeah, that song ain't bad, well, that's not really an effective response, right? If the response is, yes, I had the same problem, but it was different in this way, then that would be a slightly more sophisticated response. If it's, yes, I had the same problem and I got it to work by doing this, then you get more marks for that. And if it was, I never had that problem, but it sounds like this, this, and this, and then the person responds afterwards and says, yeah, that fixed it, then that would be your best group contribution. Does that make sense?
Yes.
So we only get the marks if it's actually useful.
No,
and it actually works.
You're getting marks for contributing. You'll get the most marks for if it actually works. So you get no marks for sympathizing, but you'll get marks for helping. Does that make sense?
Yeah, and what do you mean by the group contribution?
So that is the group contribution. You're contributing to the wider group.
But that mark goes to your individual mini project.
Yes.
Okay.
Mm-hmm.
Okay.
So you will individually get marks for the help that you provide to other people with the same project. Let me just verify that I have the settings on that correct. It should be set so that the forum you see is based on the project you are assigned. I just check in, right?
Hmm.
I have another question.
Mm-hmm.
So I know I asked to update the wiki weekly, but let's say you don't do that and then you just do everything at the end. Would you not get as much marks as if you
see all this conversation we've been having about workload and students waiting until the 2 days before the deadline to upload things?
Mm-hmm.
I'm letting you know that is not going to work for this.
Okay.
So if I see a student who was uploading weekly and got stuck, right? They would get more credit for being consistent because they would have, uploaded, this is the problem I'm having. They'd uploaded, this is the problem I'm having. I fixed this problem. So we would have seen their progress, right? Because remember, our goal is to assess how you're approaching a problem that you haven't seen before, right?
Yeah.
If we see it's working perfectly and we get everything uploaded the night before, then we can't judge your process, right? So even though you would get marks for the result, you wouldn't get marks for your process. Does that make sense?
Yeah.
All right.
And
that would also call into question whether you did it yourself or whether you got help, right? So if you want to verify that, no, I did it myself. I got help by checking the troubleshooting tales, but I did it myself. Then post regular updates, okay?
Okay.
So the point is we want to judge how you've been approaching the problem. So we're asking for the weekly updates so that we could see how you're going. And also, as we are monitoring, we might be able to send you a private message and say, I see you're struggling with whatever, make an appointment. Or I see you had this problem, try this, right? So you give us the opportunity to help you as well. Whereas if there's nothing on there until the night before it's submitted, then you don't give us that opportunity to help you. And in fact, that is one of the challenges we had with assignment B, because for weeks I was asking people, okay, have you read assignment B? Do you have any questions about assignment B? And even if you never started assignment B, Joshua will tell you that if he had read the whole of assignment B, he could have asked some of those questions earlier, right, Joshua?
That's true.
All right. So what I'm saying is I appreciate that you want to get the perfect thing and you want to give us perfect work. But this is engineering. The work is never perfect, right? You always will be making some kind of compromise. So the three things I want you to take away are: one, that there's no right answer and it's not to be found out there on the internet. You need to think it through. Number two, we want to look at your process. So just giving us the final right answer is not a good idea. And three, it really is not a good idea if you never get to the final right answer, because then we have nothing to judge you on at all. Okay? So it's in your interest to give us the continuous as you progress, so that then we could see how far you got and help you. All right? But thank you for asking that question. Kamrash, I don't think I heard from you today. Anything you need to know? All right, but the last practice code that we left you with, everybody was good with it? You could either unmute and tell me, or you could type me a note in the chat. I think the last practice code we left you with was what, Mikhail?
Just give me 1 second.
Okay. Normally, the last session we would devote, the second to last session would be devoted to indirect addressing, which we just reviewed in the full class review. And the last section would be devoted to ports and peripherals, which we just looked at in the context of assignment B and the HD peripheral. So in terms of the things I know people have problems with, I know I've addressed them. So, but if anybody has specific issues with indirect addressing or ports and peripherals, now would be a good time to ask. In next week's review session, we'll be using MPLab, we'll hook up to a board and we'll be looking at the three peripherals again. And the three peripherals that we're using this year are the serial port, the A to D converter, and is timers. No, it's timers and something else, PWM. So if you have any queries or you want to practice using those peripherals, join us in the review sessions next week. Any luck, Mikhail?
The last thing I'm saying here is the BCD hypo.
BCD hypo, okay. Anybody had any issues with representation on BCD? You're gonna need BCD for displaying the digits. Well, we only using one 8-bit display on our practice board. But BCD is useful anytime you want to display multiple 7-segment digits. So any queries about BCD? All right. Okay. Well, we have 3 minutes. It's 3 minutes to 9. I know you all have other things to do because you all are busy. It was great having you all in remedial for this time. If you have any other queries, does everybody know how to make an appointment to meet with me if you need one? Other than that, good luck. You'll have to check the calendar, Joshua, because you know
Yeah.
I don't remember.
Yeah, I look at the calendar, I see 25th
It says the 25th of what?
April.
On the calendar? You want to share your screen?
Yeah, I can share my screen. Let me see. Share screen.
All right, what it says.
Mini project. Well, I'm looking for the report.
To the
Report.
right. To the right.
Oh, my bad. Report 3 final exam review. So the 25th.
To the right. So if you were giving me an oral report in class or asking for assistance, you should have done it last week or this week come in, right? I realize everybody's behind schedule. And what is in the right-hand column?
Oh, my bad, sorry. Mini project demos by appointment, May the 14th. Mini project, oh, mini project cookies, those on May the 14th. Okay. So the report needs to be done by that time. So, what is meant by the mini project oral report?
Well, the mini project or a report is supposed to be y'all telling me how you're getting along with your mini project, but nobody's been doing it.
How do we do this?
You come to the session and we say, report. You can also put a recording on your wiki.
Oh, okay. So you mean like when we come to class, we say, all right, this is my report.
I'm having a problem. Yes. So we call it the 1 minute report, right? Which is literally, this is where I am and this is my problem.
Oh, okay.
And you can do the same reports by doing a recording and putting it on your wiki. Did you test the recording feature? You know how to do recordings and put them on your wiki?
Yeah, I know how to do the recordings.
All right. So put up your oral reports in your wiki as you progress with your project, okay?
Yep.
So I'm expecting, so the project should take you about 4 weeks. You have time, right? If you start.
Yeah. Well.
And basically you're gonna put up an oral report every week. If you look in the marking scheme, you'll notice that we have marks for reporting and login, right? Project parts and assessment information.
And reporting and logging.
Excuse me.
Hi.
Just more.
Item 6. I listening.
Almost I forget, but I should remember just now.
Not a problem.
So 10 oral report logs must be done in this report.
No, 10 marks for the oral report logs that you put in your wiki.
Oh, okay.
And it's for troubleshooting and revision, right?
I understand. So much more.
You see? You also notice we're giving you 5 marks for breadboard layout. So all those things that everybody got poor marks on in the lab practice.
Oh, that was the whole lab practice.
Right. When you take a picture of your final thing, or when we're looking at you in your demo, we're giving you 5 marks for breadboard layout. We want to make sure that you laid out your breadboard with the correct color codes, etc. Right?
Yeah.
Same. There's 5 marks for code formatting.
The demo, right? That's we doing that over video.
You're going to do that over video. You see, it says not accessed via wiki. You're going to do that over video with an appointment, and you're going to make the appointment using, there's an appointment link, right?
I'm gonna say project overview and
right at the bottom.
Individual product damage. Oh, okay. Okay, cool. I understand. Yep.
We good?
Yeah.
All right. So who was the other person with the question?
Oh, Mason, I remember. Mason, like he was talking about accessing libraries.
Yes, very good. Okay, so you have to use an LCD. And I also had a question from somebody if they could do the project in C or assembly. And I said either. It doesn't matter to me. You'll notice in the marking scheme, we don't penalize you either way, right?
Okay.
But you should use good code practices regardless. Now, I didn't give you code practices for C, but you should already have code practices for C from programming, right?
Yeah.
So you all know how to indent your code and comment your code and all those other things, right? I'm not supposed to be running into some strangely formatted code, right?
Mm-hmm.
All right. Yes, go ahead and leave for the CSL meeting, whoever that is. Go ahead.
Okay, thanks, miss. Enjoy the rest of your day.
You too. So
That
the
kind of
libraries, right?
is a
Okay, so the LCD
completely
libraries,
kind of
yes.
different way of learning.
Oh my.
Honestly, I don't imagine anything worse than micro P right now.
Yeah.
That's our problem for future us, dog. Just leave it.
Oh, they're talking about the individual mini project there. Or...
Talk about semester 1, year 3.
Oh, I don't want to think about that as yet.
AFT is semester 2. Yeah. Semester 1 is accounting and management is a compulsory course.
Oh.
What about that one? That was nice.
Well, it's accounting and things, so most people. Well, I really didn't like that course. I barely passed it.
Uh-huh.
The exam was like a whole report last semester. You had to write a whole report
So if
on
I
it.
did POE, right? Can I get
Yeah.
through that course?
Well, it's not much accounting, but it's a lot of management stuff. So
Okay.